All right, well, let's keep it going. Yusung, I think you got the next one.
Sure, yep. This is an example from Roman Osipov from Russia. I like this example because it uses a built-in mathematical function very well, and it also has a very educational value on it. So what the Roman did here is using Boolean function. I will describe what it is a little bit later. And using that, he drew the set of three Venn diagram for three sets, and it shows all the combination of these Boolean functions, like the or, and, and everything, negations, and of course in a sense it can replicate the complement too. So as you can see, all possible combination of those a different type of Venn diagram is showing here. So I will describe it a little bit how it works. So essentially, first he used the Boolean function, which is I think it newly introduced in version 7, I believe, and it gives you all the sets of the Boolean function with the given variable. For instance, Boolean function of the 1 x, y, g means it's a first function in the set. I mean, no, actually, it's a second function because the index goes from 0 to the n. So this is the Boolean function which combining this x, y, g, and it always returns predicate on this x, y, and g value. Of course, it can be a two variables too, and the first number is the it can change between the all these combinations. So the number of the functions you have with those certain number of variables are defined by 2 power of 2 power of n, where the n is the number of the variables. So let's say you have two variables here, then what you get is 16 Boolean combinations. So you can say, of course, the 15 is the last one. It's true. The 0 is the first one, which is always false. And in between, you get all possible combination of negation and then or. Now, using that, that's pretty interesting. So you get that. So essentially, he rotate those functions by the 1 from 1 to the 2 to the a. Now, actually, if it's technically correct, it has to be 0 and 2 to the 8 minus 1. Now, the thing is, actually, it's just cyclic. So when you hit the bound, which is in this case 2 to the 8 minus 1, it goes back to 0. So he actually saved a bit by not introducing minus 1, but just going ahead with using the fact that it is actually cyclic structure, which is also a neat trick here. Now, another thing is, now how you draw the Venn diagram itself, these circles. So he create three circles using these particular centers, and this is applied at level 1, and he applied that to the radius 2 circle with these various circle. I was actually trying to find out whether there's a shorter way to do this. Unfortunately, our function is I mean, I was thinking, for instance, using something called the Euclidean distance because it's obviously Euclidean distance. Now, our function name is pretty long, Euclidean distance. I'm pretty sure that's longer than this. So. And applying that to this Boolean function of your choice. Now, the fancy thing about this Boolean function, it can take these sets and it returns predicate on these particular set types. You can actually just plug that into the x, y, z, then it returns actually symbolic returning of these particular Booleans. So it WCG of predicate as well as the labeling. And then what you're ending up getting is very nice representation of these all sets. And one thing you would notice, especially if you were new to Mathematica, when I move these sliders, you will see the picture is not perfect, but when I stop moving, then you finally get the perfect. This is something we call adaptive sampling. So when you're moving around, because of the speed, Mathematica is aiming for the speed, how fast it is. So it drops down the quality of image a bit. Then when you drop the control, when Mathematica knows that you just stop moving, then it shows the perfect quality. In this case, if you understand computer graphics, you will find that drawing this kind of reason plot with this accuracy, like this tiny, the corners, this is pretty hard. And Mathematica actually does some sort of symbolic process to achieve this, not with this delicate, images. So I think this is a very good example. Also, the good thing about this example is you can actually take this example and you propose it for your classroom. For instance, you're a teacher. It's a great example. I mean, drawing Venn diagram without hand, not manually, but automatically is not easy task. And this example actually shows how it can be very easy in Mathematica.